So today we're going to start taking a look at multiplying complex numbers. So we've already in class discussed how to go and add and subtract complex numbers by combining your like terms, your reals to your reals, your imaginaries to your imaginaries. Then the other day we talked about powers of I, and that's a big thing that we need to remember when we start multiplying, because as we're multiplying imaginary numbers, we're going to end up with these powers of I, right? So, one thing that we need to really make sure that we remember is, again, this most important relationship that I squared equals -1. Because in that relationship, we can see how an imaginary number becomes real. Okay, so I to the first is just equal to I squared is -1. If we have an I cubed, that's a negative I, and if we have an I to the fourth, that becomes a positive 1. All right. Another thing that we need to remember as we're going and multiplying these complex numbers, all of your answers must be written in standard form. Standard form is a plus bi. You could also write it as a minus bi if the imaginary component was negative. But we always have to put the real value first, followed by the imaginary. Okay, remembering that a is our real component and that b is our imaginary component. All right, so we're going to take a look at a few examples of how we're going to go and multiply complex numbers together. Okay, the first two that we have are the more basic ones, and that's because we're multiplying just a pure imaginary number like 2i to a complex number such as 3 minus 4i, right? So as we're going and trying to do this multiplication, we're going to use the distributive property. Remember that this set of parentheses right here implies multiplication. So I need to distribute this 2i to each of the terms that's inside the parentheses, okay? So writing out what that means, we're going to have really this is 2i times 3, and then we're also going to have a 2i, and it's going to get multiplied by a -4i, okay? So if we just do some multiplication, we can remember that we're going to multiply the real components to the real components and the imaginaries to the imaginaries. So in this first example, 2 is a real number, 3 is a real number, multiply them together, you get 6. It's an imaginary, so that's 6i. Over on the other side, 2 is a real number, -4 is a real number. That generates a -8. But then I have I and I. Those are imaginaries. Anytime you multiply the same thing by itself, you get an exponent, right? So that's really the same thing as I squared. But what is I squared really? It's really that -1. So we could say that this statement is now equivalent to 6i minus 8 times -1. Okay, well, what's -8 times -1? Well, +8. Okay, so writing that in standard form, the 8 is the real number value, so it goes first. The 6i is positive, so plus 6i. Okay, again, we're writing the answers in standard form, which is why I had to go and write the 8 first, then followed by the 6i. Okay, so for the next example, I'm not going to show you kind of all the intermediate steps. I'm assuming you guys can kind of pick up on that relatively easily. So we're going to go and start working on the next problem. All right, so we've got this -I, and we're going and we're multiplying it by 2 plus 3i. Okay, so we're going to use the distributive property again because these parentheses imply multiplication. So we're going to multiply the -I by 2, and we're going to multiply the -I by 3i. So that is going to generate a -2i from the first product, and then it's going to give me -3i squared for the second product. That I squared, just like before, isn't really I squared, it's really a -1. So this is -2i minus 3 times negative 1. And then we're going to write that in standard form, simplifying it out. So we have a negative 3 times a negative 1, which gives me a real number of 3. That number gets written first. And then minus 2i. Okay? Easy peasy, right? Basically the same thing as multiplication of a algebraic monomial times a binomial. It's the exact same thing. The only real difference is that when you're looking at like this x squared kind of guy over here, okay, we're just remembering that, well, that doesn't really stay I squared. It gets converted into a negative 1. All right, so let's take a look at two other ones, but this time we're going to kind of notch up the difficulty just a little bit. All right, because in these two problems, we have a binomial times a binomial. So we're going to have to use the distributive property. Okay, some of you may have heard it referred to in other classes using a four-letter F word. I'm talking about FOIL. Okay, this is a public high school. That language is filthy and inappropriate. But we're going to go through and never use the acronym FOIL. Okay, it's the distributive property. We should be past the point intellectually where we need to give everything a cute nickname to remember how to do it. So we're going to be using the distributive property. So that means that this value of 2 is going to get distributed to each of the terms in the second binomial, and the 6i is going to get distributed to each of the terms in the second binomial. So let's go through and write that out, and I'll try and keep it color-coded for you. So first we have the 2 getting multiplied by the 5. 2 times 5 is 10. Then we have the 2, and now it's getting multiplied by the 2i. Well, the real number 2 times the real number 2, or negative 2, is negative 4. And then we have an I there as well. Okay, so then I'm going to go look at the next distribution. So I have this 6i, and I'm going to multiply it by 5. Well, 6 times 5 is 30, and it's positive, so plus 30i. And then we have 6i times negative 2i. Well, 6 times negative 2 is negative 12, and then I times I is I squared. But, lo, what is I squared? Ha ha ha, that's right, it's negative 1. So if I start by trying to simplify all this, I can combine my like terms that are sitting here in the middle because those are both pure imaginary numbers. So I have this 10. I can say plus 26i because that's what negative 4 and 30 is. And then minus 12, but that's not really I squared, that's times negative 1. Well, thinking what's negative 12 times negative 1 and coming out with positive 12, well, that would be 10 plus 26i plus 12. And then I could combine those two like terms to get 22 plus 26i. It's written in standard form, the real numbers first, the imaginary numbers second, so I must be good there, right? So as long as you can remember to use the distributive property and convert all your I squareds to negative 1s, we should be in business. All right, so the last one that we're going to take a look at here is example number 4, where again we have a complex number getting multiplied by another complex number. All right. However, when you look at this, you should notice that those two complex numbers look almost the same. There's just one teeny tiny difference. This one's got a boop and that one's got a bip. Okay? Other than that, they're exactly the same. So hopefully you remember from when we started this unit that there was this thing called a conjugate. And if one complex number was a plus bi, its conjugate was a minus bi. So here's an example of two conjugates. And mathematically, something actually kind of cool happens if you're into nerdy math stuff, which I am. I do this for a living. So anyway, I'm going to go and actually multiply these two things together. So using the distributive property, I've got 5 times 5, which is going to give me a nice pretty 25. And then I've got 5 times negative 2i, which gives me negative 10i. Okay? So then I'm going to take positive 2i times 5, and that's going to give me a positive 10i. And then negative or positive 2i times negative 2i, well, that's going to go through and give me a negative, that's a negative sign, 4i squared. All right, so what terms can I combine because they're like terms? Oh, well, I've got my, imaginary numbers in the middle, but oh my, a negative 10i, a positive 10i, they go bye-bye. Okay, they're the same value but opposite directions, so they nullify each other. So that's just like gone. And then this I squared, I know is really going to be negative 1. So we've got 25 minus 4 times negative 1. Well, what's negative 4 and negative 1? Well, positive 4. So this is really the same thing as 25 plus 4, which is just the real number 29. There's nothing imaginary there. Interesting. We made the point of saying that this was like this conjugate thing at the beginning, and then we did some multiplication with this conjugate thing. And instead of getting a complex number, we got a number that's all real. Man, I wonder how that's going to come into play later. You'll just have to wait to find out.